This is now section 5, managing cyber resilience operation controls and alignment with ITSM. We will be dealing with the operations controls for cyber resilience and their interaction with the ITIL processes. There will be 8 questions in the exam from this topic. And if you have completed our RESILIA Foundation training, you may skip all content in this section except slides 290 through 292, which is about just 3 slides added here. The exam syllabus is to, first of all, go through the purpose and the use of the 5 controls here, namely access control, network security management, physical security, operation security, and incident management. And there are also 9 ITIL processes which interact with cyber resilience. And these are event management, incident management, request fulfillment, problem management, access management. In fact, these 5 are the processes. I should not be saying 9 processes. We have 5 processes. But then there are 4 of them which seem like processes, but they're actually functions because functions can carry out 1 or more processes. So these are service desk, technical management, applications management, and IT operations management. For example, service desk function could carry out incident management and request fulfillment. So therefore, a function is like a group of people who can perform several activities which are connected with 1 or more processes. Sometimes multiple functions may be needed to take part in a single process. For example, technical management, applications management, they will have their say for event management. Cyber resilience operation. Everything that was done in strategy, then design and transition is now put into use in preventing, detecting, and resolving cyber incidents. It should be emphasized that the main goal of cyber resilience controls in service operation are to prevent, detect, and correct cyber incidents. So the controls that have been put in place to protect the organization's assets actually have an effect during operation. In the life cycle, most time is spent in operation, and we can see that in the picture to the right, where you have the tiny circle inside, which is the strategy duration. Then we have design, a bit purple there, the triangle or the arc section there, and then which is a little bigger. And then we have transition, the darker part in the arc triangle there as well, which is even tiny. And operation is much big. And then we have continual improvement at the periphery. Organizations that do not have formal strategy also or design and transition still will have operating cyber resilience controls. And that's because they would like to first implement and operate controls and then later on develop their strategy and design to improve their cyber resilience. That may be because they are in a rush to get into operation and therefore they will intentionally overlook strategy and design and transition. It might not be such a good approach, but some organizations may end up doing that due to certain constraints. Now, a good starting approach can be the UK Cyber Essentials Scheme. And you could take a look at that. The content of that is not part of the exam syllabus. But this is something organizations can use as a starting approach to establish certain controls to start with. These controls must be integrated with all aspects of running the business to provide protection that is required while having smallest possible negative impact on efficiency and effectiveness of normal business operations. Now we have a long list of controls applicable for cyber resilience operation. And the control objective in operation is to ensure that the risks to the disruption of operational services are managed. So we have access control, and then we have network security management, physical security, operations security, and cyber resilience incident management. So there are 5. However, within access control, we have several topics: logical access control, business requirements and access policy, authorization, registration, and provisioning, identity verification, secure use of systems, authentication and credentials management, which is slightly different from identity verification. Then we have the JML process and access management. JML is for joiners, movers, and leavers. And then access monitoring, review, certification, and compliance. Then we move over to network security management, which is made up of the following: network switch and logical segmentation, detecting and preventing intrusions using IDS, IPS, those are the intrusion detection and prevention systems, monitoring and logging after that. Then we have external network connections, firewall management, remote maintenance, wireless access, protecting networks from distributed denial of service attacks, DDoS. Then under physical security, we have the following: physical access control, perimeter security, visitor management, identity badges and passes, equipment siting, cabling and labeling, protection of supporting utilities, security of unattended equipment, operations security, cyber resilience, incident management. So the last two, operations security and cyber resilience, incident management, are controls on their own. And the others, the three earlier, have many sub-controls. So you might notice that there are several technical controls here. And we had also in transition as well as design, we had some technical controls. So let's get into each one of these and understand what these controls really imply. We begin with access control, which is probably the most important of all controls. Access control ensures that only authorized entities have access to the assets and that the access granted is appropriate within the principles of least privilege and need to know. And those will be explained a little later on. So here we have the logical access control. This means access via digital means to information systems and networks. On the other hand, we have physical access, which is basically protecting facilities, etc. And it can also be electronic access controls to buildings and office areas based on assets contained there. So those are known as physical, whereas logical ones are the digital access to information systems and networks. And the way of working should be that minimum level of access rights should be granted to legitimate users or systems, and to completely stop access from unauthorized users or systems. So that's relating to least privilege and need to know, and we will come to that afterwards. Without access control, the confidentiality, integrity, and availability of sensitive and valuable information cannot be assured. So access control forms the very foundation of cybersecurity and resilience. Now we have logical access control. We continue with that. Information is also covered by law to preserve confidentiality. For example, personal data, financial data, medical records, criminal records, intellectual property, research and development information, business strategy and risk registers are example of sensitive information. And an organization normally will not want everyone inside it to have unlimited access. Of course, they may not allow access to those who are outside the organization. And that's because disclosure of personal data and these kind of sensitive information can cause reputational damage and attract financial penalties, particularly personal data. And disclosure of intellectual property can also cause financial loss. And we have dealt with this a little bit earlier, industrial control systems like SCADA, and the loss of confidentiality or integrity of that could have severe implications for national infrastructure. So organizations subject to data breaches lose the trust of their customers and confidence of shareholders and markets, resulting in huge financial losses. If it's a government organization, loss of such personal data could lead to loss of public confidence with regard to sharing people's information, thus affecting the organization's ability to provide public services. Next, under access control, we have business requirements and access policy considerations. And that means all access control should be aligned with the organization's access control policy, which means that should specify roles and responsibilities for authorization and process for verification of the identity of someone, minimum access rights and review of access, certification of accounts, level of auditing and compliance required. All these need to be put in place. Then the actual authorization, registration, and provisioning. That means all access need to be authorized. It's a must. And those who are owning the asset or responsible for the asset should authorize the access to their assets that they own. And in case of information or data, it is usually the asset owner, meaning the information or data owner. In other cases, it could be delegated. In fact, in all cases, it could be delegated, but it's not uh, okay to delegate the accountability of the authorization. So I could be the owner of an information asset, and I'm supposed to authorize access to the asset, and I could delegate it to someone else as well. But if something goes wrong, then I'm accountable for it, not the one to whom I delegated. Application and system owners perform authorization in some cases, and it should be a senior person with required authority. And larger systems may automate this using an access control system.